Okay, so now we have another theorem here. I think we did, yes. So we have another theorem here, theorem number 3, or theorem 3, which is the number of permutation of n objects, the number of permutations of n objects where p objects are of the same kind, and rest are all different, and the rest are all different, is equal to n factorial over p factorial So of course you know that the permutation of n different objects taken n at a time, that would be basically the permutation of, so the number of permutations of n different objects taken n at a time would be equal to basically, well, n permutation n, which is equal to n factorial over n minus n factorial, which is equal to n factorial. That's where this n factorial comes from, right? And then since p objects are of the same kind, you want to take out those p factorial, you want to take out that p factorial. That's why basically you divide by p factorial, and so you'll end up with n factorial divided by p factorial. And it seems that we have a more general theorem. And well, these theorems of course don't come with proofs, so we don't prove them, but we can use them. So theorem number 4, we have the number of permutations of n objects, the number of permutations of n objects where p1 objects are of the same kind, where p1 objects are of the same kind and p2 are of the second kind, p2 are of the second kind, and so on and so forth. P of k are of the kth kind, and the rest, if any, are of different kind, and the rest, if any, are of different kinds, is going to be basically, so you have the number of permutations of n objects. That would be simply n factorial. And then you have p1 objects that are of the same kind, p2 objects of the you would say of the one kind, or of the first kind, I would say, for example, of the first kind, I would say. And p2 are of the second kind, and p of k objects are of the kth kind, and the rest, if any, are of different kinds. That would be n factorial over, for example, p1 factorial times p2 factorial, all the way up to p of k factorial. So that's basically what we have done, what we have seen so far in our examples. Now, as an example, let's do example number 9. Example number 9 is find the number of permutations of the letters of the word Allahabad. Find the permutations of the letters of the word Allahabad. Allahabad. Okay, so what this question means is that you want to find the permutations. So permutation, what permutation means the different arrangements. This means the different possible arrangements. The different possible arrangements of the letters of the word Allahabad. So what that means is that you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9. Let's suppose that 9 different objects. And since you just want to rearrange them and put them back together, so you would get basically the 9 different objects back, meaning that you have 9 different objects taken all at a time. If it was, for example, meaning that, in other words, you could ask this question this way. So how many words with or without meaning is it possible to make using the letters of the word Allahabad, if assuming that no repetition is allowed. And when we say that no repetition is allowed, what that means is that basically when you For example, suppose that now I'm going to treat, for example, these A's as different A's. For example, A1, L, or L1, L2, for example, A2, H, for example, A3, B, A4, for example, D. I have these letters here. Now, when I say no repetition is allowed, that means that when I take, for example, I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. I have 9 different letters here. So 9 different letters here. If I have 9 different letters here, that means that basically the first placeholder when I want to make these new words, I have basically 9 different ways of filling this first placeholder. And now since I have chosen any one of these letters for the first placeholder, then of course logically I will have only 8 different letters to put here. And again, since I've chosen 2 here, 2 of the letters for these 2 placeholders, then 9 minus 2 would be 7 letters remaining here, 6 letters remaining here, 5 letters remaining here, and so on and so forth. And so this assumption of repetition not allowed is actually built into the word permutation. That means that when we say permutation, that means that we are assuming that we are not repeating anything. Otherwise, we would mention that we are actually repeating, and so that the formula is going to change a little bit slightly. And so this question can be asked this way: how many words with or without meaning is it possible to make using the letters of the word Allahabad, assuming that no repetition is allowed? The same thing is basically the same thing can be asked a little bit more technically as find the permutations of the letters of the word Allahabad. And that's it. That's the end of the sentence, right? So now, assuming that we understand the question, let's try to solve it. So to solve this question, what we need to do is basically here I assume that basically there are 9 different objects here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And since I made this assumption, now since I can assume that there are 9 different objects here, but I know that, for example, A has been repeated 1, 2, and 3, and 4 times. So A appears 4 times. And then for example, L appears 2 times. L appears 2 times. And then for example, H, B, and D. So that's it. That's all the information that we have. Now, if I were to calculate the permutations of 9 different objects taken all at a time, that would be 9 factorial, right? So the required number of permutations, would be equal to basically, for these 9 different objects, I have 9 factorial permutations. And then, of course, I have to take these out, meaning that, for example, since A has appeared 4 times, again, I would get into that problem of the word root, right? So I had these two O's over there, and then I would get all of those repeated results. So that means that I have to calculate the permutation related, or the permutation related, for example, to these two O's, and then divide this expression by that value of the permutation. So what that means is that I'm going to basically, if I had basically 4 letters, basically, if I had basically 4 objects, and if I were to calculate the permutation related to 4 objects, that would be simply 4 factorial. And again, I have another 2 objects, and I need to calculate the permutation related to those 2 objects. So that would be another 2 factorial. So the required number of permutations would be 9 factorial over 4 factorial times 2 factorial, which is the same thing as basically 4 factorial times 5 times 6 times 7 times 8 times 9 divided by 4 factorial times 2. These two you can cancel out, and then that's a 4, so that's the same thing as 36 times 42 times 5. 36 times 42 times 5, which is the same thing as 12, 1, 7, and 24, 2, 12, 14, 2, 11, 11 and 5 and 1, and times 5, that would be multiplied by 5, we'll get 5 times 2 is equal to 10, 1, 6, 25, 2, 5 and 7, 7560. 7560. So that's the required number of arrangements or permutations related to this situation, right? And question number, we have another example here, example number 10, that says how many 4-digit numbers can be formed by using the digits 1 to 9 if repetition of digits is not allowed. Okay, so you want to calculate how many 4-digit numbers can be formed. 4-digit numbers can be formed using the digits 1 to 9, using the digits 1 to 9, repetition not allowed. Not allowed. So since repetition is not allowed, I can use the formula related to permutation, n permutation r, which is n factorial over n minus r factorial. Now over here, basically the number of digits that I have, which is n here, is 1 through 9. So you have basically 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so that's 1, 2, 3, 4, 5, 6, 7, 8, and 9 numbers. So that's basically 9 factorial. And since I'm creating these 4-digit numbers, my r is equal to, so n is equal to 9, and my r is equal to 4. Now since my r is equal to 4, so that's 9 minus 4 factorial, which is the same thing as 9 factorial over 5 factorial, which is 5 factorial times 6 times 7 times 8 times 9 over 5 factorial. And we can simplify this. You get 42 times 72. That's 84, 0, 14, 1, 28, 29. So you get 4, 12, 1, 0, 3, 0, 2, 4. 3, 0, 2, 4. And or another example that we have here is you want to know how many numbers lying between 100 and 1000 can be formed. How many numbers lying between 100 and 1000 can be formed with basically with the digits, or basically using the digits 0, 1, 2, 3, 4, 5. If the repetition of the digits is not allowed. Repetition of the digits not allowed. Okay, so in order to understand that, so how many numbers lying between 100 and 1000 can be formed using the digits, using these digits, repetition of the digit not allowed. So I would simply use n permutation r, which is equal to, as you know, n factorial over n minus r factorial. But the problem is that I don't know what my r is. I know what my n is. Basically, my n is basically 0, 1, 2, 3, 4, 5. So that's basically 6 digits there. There is 6 digits there. So that is basically my n. Now my r, I need to know how many, basically, what sort of numbers I want to make, meaning whether I want to make 2-digit numbers, 3-digit numbers, or what do I want to do. So I know that my numbers are between 100 and 1000. So 100 and 1000. So basically the numbers go from 101 all the way up to 102, 103, all the way up to 999. So all of these numbers are 3-digit numbers. So that means that r is equal to 3. And so but there is a problem here. You see over here I have the digit 0 as well, right? So when I use these digits in order to construct these 3-digit numbers, the problem is that 0 will, basically there will be the case that you would start with 0 and then you would have all of these 5 choices there. So you would have basically 1, 2, 3, 4, and 5. So you would have these cases here, and then after this you would have only basically 2, so 4 choices here. So 1, 2, 3, and 4. So 2, 3, 4, and 5. And then you would have, for example, 3. So you would have, for example, 3, 4, and 5 over there. And then for these choices, you would have, for example, you would have basically, for example, 2 choices there. So would be 0, 1, 2, 3, 4, and 5, and then 5, and then 4 over here, right? So, and you would get a number of numbers over here, but the problem is that the number starts with a 0, and since the number starts with a 0, it would be something like, for example, and of course the number is supposed to be a 3-digit number, so this is actually not right. This is wrong, meaning that I would start with a 0, and then over here I would have all of these choices: 1, 2, 3, 4, 5. 1, 2, 3, 4, 4, and 5. So, and then after that I would have basically another 4 choices, meaning that then over here, for example, I would have 2, 3, 4, and 5. 2, 3, 4, and 5. So that would be, for example, this way. And then the same thing happens over here as well. That means that these 3-digit numbers over here, you would have 6 different ways to fill this place value. You would have 5 different ways to fill this place value, and you would have 4 different ways to fill this place value. Now the problem is that one of these numbers happens to be 0. And if I have, for example, some number like, for example, 092. 092 is a number that starts with a 0, and then you have a 9 and a 2 there. It's actually a 2-digit number. It's not a 3-digit number. It's a 2-digit number. So you want to take these out. So what that means is that we have to somehow take all the permutations of this 0 out. And what that means is that basically, how do you calculate the permutations of 0? Okay, so now there are actually 2 ways to think about this problem. I mean, there are two ways to think about how to take out these numbers. So you see, the numbers are basically something like this, meaning that you have all of these digits. You have all of these digits here, 0, 1, 2, 3, 4, 5, 6, which is 6 digits, right? So your n is equal to 6. And you want to basically make, using these 6 digits, you want to make 3-digit numbers. So r is equal to 3. So then what that means is that then using this formula, you can calculate, for example, 6 permutation 3, which would be equal to, for example, 6 factorial over 6 minus 3, which is equal to 3 factorial, which would be basically 3 factorial times 4 times 5 times 6 over basically 3 factorial, which is the same thing as 120, right? Which is the same thing as 120. Now, we have another part here that we need to basically take care of that. And that is basically all of these numbers that start with a 0 and then you have all of these other digits over here. Now you want to basically exclude all of these numbers. So how do I find the number of these numbers? I can think of these numbers as 5 permutation 2. 5 permutation 2. Because basically, as when it comes to basically these two digits, I'm assuming that I'm not using 0 here, right? So 0 has been used here, so I'm not using 0 in any of these two placeholders. So if 0 is not being used, so I have 1, 2, 3, 4, and 5. So that means that then my n would be equal to 5, and my r would be equal to 2. So then 5 permutation 2, which is equal to basically 5 factorial over 3 factorial, which is equal to 3 factorial times 4 times 5 over 3 factorial, and that is equal to 20. So then you need to basically subtract this from this, meaning that then you could say that the required number is basically 120 minus 20, which is equal to 100. So one more way to think about this is that to take out basically those numbers starting with 0, and then you have these two digits here. So there is only one way of filling this placeholder with a 0. There is only one way of doing that. And then you have all of these digits, all of the remaining digits except for 0, which means that you could use basically 5 digits here. And meaning that there are 5 ways of filling this placeholder. Once you do that, then meaning that you have used any of these digits except for 0. Suppose that, for example, you've used your 0 over here, and then you've used, for example, 1 over here, and then there is all of these remaining here. So that means that there are 4 ways of filling this placeholder with digits. And so then you can, by the fundamental principle of counting, there is basically 1 times 5 times 4 different ways of filling these 3 digits, which is 20, the same number that we got over here, or the same number that we got over here. And so then 120 minus 20 is equal to 100. So that's basically how you solve this problem. It's a little bit, a little bit tricky, because especially because you don't, I have done this chapter one time before, and the first time that I solved this problem, I didn't actually account for the 0 basically starting here and then the number becoming a 2-digit number, and so even the second time right now that I wanted to solve the problem, I didn't account for that. So you need to be careful with that sort of thing. So the next thing that we have here is question number 12, which is given the value of n such that basically, okay, you want to find the value of n. So these are as I remember, also a little bit tricky, but I mean it's somehow related to the factorial notation. That's not a problem. But if you're not still very good at the factorial notation, you might find these a little bit tricky. So for example, if you have n permutation 5 is equal to 42 times n permutation 3, and here n is greater than 4, and you want to find your n. So I suppose what you can do is that you can write this as 42 is equal to, for example, n permutation 5 divided by n permutation 3. And you know that n is greater than 4. Now what I can do is that, well, you know that basically n permutation 5 is the same thing as n factorial over n minus 5 factorial, and n permutation 3 is the same thing as n factorial over n minus 3 factorial. And so what that means is that this is equal to 42. Now you need to simplify this, meaning that I can simplify when you have this kind of thing, for example, a divided by b divided by c divided by d, for example, that's the same thing as a divided by b times d divided by c, which means that you can simplify. You're multiplying a by d, you're multiplying a by d, and you're multiplying b by c, right? So of course you can simplify a and b, right? So for example, if you had, for example, 6/4 divided by 5/10, you could simplify these two together, you could simplify these two together. But additionally, you can simplify a with c, because this is in the numerator, this is in the denominator. So you could simplify a with c, and also you could simplify d with b, meaning that b and d, meaning that the two numerator, you can simplify them, and these two you can also simplify them, if it's possible. So what that means is that so of course I can, for example, I can simplify a with c, right? So that means that a with c I can simplify, so that means that n factorial and n factorial I can simplify. Or if it's confusing, I'm not really very I prefer rewriting my fraction, meaning that I would much rather write this as n factorial or n minus 5 factorial times, for example, the reciprocal of this, which is n minus 3 factorial times n factorial over n factorial. And now I can simply simplify these, and this is equal to 42. And so that means that n minus 3 factorial over n minus 5 factorial is equal to 42. Now you need to simplify this, right? So when it comes to n minus 3 factorial and n minus 5 factorial, what that means is that I need to rewrite these so that I can simplify them. And the meaning of this, the meaning of n minus 3 factorial is, for example, n minus 3 factorial, the meaning of that is 1 times 2 times 3 times all the way up to n minus 3. And the meaning of n minus 5 factorial, the meaning of n minus 5 factorial is the same thing as 1 times 2 times 3 times all the way up to n minus 5. So of course, if you subtract a 1 from this number, you will get, of course, to the previous number, because you as you can see, for example, I have over here 1 times 2 times 3 times 4 times 5 and so on and so forth. So that means that to get to this number, if I write 5 minus 1, which is equal to 4, that gives me this number. If I write, for example, over here 4 minus 1, which is equal to 3, it gives me basically this number, and so on and so forth. So I have to subtract 1 from each of these numbers to get to the previous number. Which means that, for example, this thing over here, I can write it as, for example, that the previous term relative to this term would be, for example, n minus 5 minus 1, which is equal to n minus 6. And the previous term relative to this one would be n minus 7, and so on and so forth. So as you can see, it doesn't make any sense to get to the previous term related to this term, because the more that I move towards the previous terms, this number is getting larger and larger, but somehow I want to find some way to simplify these two together. So what I can do is that I get to the previous term related to this term, relative to this term, which is n minus 4, and then n minus 5, right? And then basically all of this is being multiplied. All of these are multiplied together. So n minus 3 factorial, I can write it as basically I can write this as n minus 5 factorial. I can write this as basically this whole part over here. I can write it as n minus 5 factorial times and then the whole thing, and then based on that I can write this whole thing as n minus 5 factorial times n minus 4 times n minus 3, right? So then that means that I can write this as n minus 5 factorial times n minus 4 times n minus 5 times n minus 4 times n minus 3, right? And then over here I have n minus 5 factorial, and then this is equal to 42. These are a little bit weird in the beginning. Even now that I have worked with these for such a long time, I still make mistakes there. So you cannot expect to get proficient with these very soon. You have to work with them for at least a few years probably to get comfortable with them, right? So n minus 5 factorial and n minus 5 factorial, then you could simplify, and then you would get n minus 4 times n minus 3 is equal to 42. Is equal to 42. And then you have basically this second degree equation that you can solve, meaning that you can write this as n squared minus 3n minus 4n plus 12 is equal to 42. And I need to write my numbers better. Is equal to 42. And so I can write this as n squared minus 7n, and then negative 42 plus 12 is equal to 42, 12, 0, negative 30 is equal to 0. And then I can solve this equation. And then I can solve this equation, which is, for example, something like you could use factorization probably, which is, for example, 2 times 30 is the same thing as 2 times 15 or 3 times 5. 7 would be it's not very easy to 2 times 15 or 3 times 10. 3 times 10. I can write it as 3 times 10. And so then basically negative 10 and positive 3, that would give you negative 7, and then the product of them would be negative 30. So I write this as n squared plus 3n minus 10n minus 30 is equal to 0. And then I can take, for example, these two terms together and write it as n times n plus 3, negative 10 times n plus 3 is equal to 0, and that gives me n minus 10 times n plus 3 is equal to 0, which means that n is equal to 10, or basically n is equal to negative 3. And of course, since I know that n is greater than 4 here, so I have to reject this answer and take this as n is equal to 10. So that's basically how you would typically solve one of these problems. Or as another one, now when it comes to, some of these, we will have another one just after this exercise or after this example. If it involves R, then it gets a little bit more tricky, but they're fine, they're okay. Okay, so the next one that we have here is a little bit different. So the question is n permutation 4. N permutation 4 divided by n minus 1 permutation 4 is equal to 5/3, and n is greater than 4. So basically, to rewrite this, you can rewrite it as, for example, well, n permutation 4 is the same thing as, of course, is the same thing as n factorial over n minus 4 factorial. N minus 4 factorial. Write this properly. N minus 4 factorial. And then the denominator becomes n minus 1 factorial n minus 1 factorial over n minus 1 minus 4, which is n minus 5 factorial, which is equal to 5/3. Now, you need to, of course, write this as basically n factorial over n minus 4 factorial, and then times the reciprocal of this, which becomes n minus 5 factorial over n minus 1 factorial. And that is equal to 5/3. Now, as you can see, so you can simplify n factorial with n minus 1 factorial, and n minus 5 factorial and n minus 4 factorial. You can simplify these two together. So you can write this as basically n factorial over n minus 1 factorial times n minus 5 factorial over n minus 4 factorial is equal to 5/3. And of course n minus 1 factorial, but it's always a little bit, I mean it's not every day that you work with the factorial notation, so it takes when you, for example, when you get to the end of this chapter, you will be okay with the factorial notation, but in the beginning you have to do a little bit of warming up. So for example, to simplify this thing, of course you can write this as n factorial. You can write it as, so this is n factorial over n minus 1 factorial. So I can write this as 1 times 2 times 3. I always do this just because I don't want to make mistakes, times basically all the way up to, for example, n minus 1 times n, right? And the denominator is 1 times 2 times 3 times all the way up to n minus 1. So of course the denominator, I can write it as n minus 1 factorial, which is what it was. The numerator, I can write it as n minus 1 factorial times n. And then I can simplify these two and I'll be left with an n. So this part is an n. This part over here, n minus 5 factorial, n minus 5 factorial divided by n minus 4 factorial, that is the same thing as, I can write it as, so this part over here, the first part is just an n. Basically, well, it's always again tricky to know which, for example, if I have, let's say that, for example, you have n factorial. That's the same thing as, for example, 1 times 2 times 3 times 4 times all the way up to n. Now the term that comes prior to n is n minus 1. Then you have n minus 2. Then you have n minus 3. And so on and so forth. So as you can see, as you're getting farther away from this last term over here, so this you can call it, for example, n minus 0, right? As you're getting farther away from this term, for example, this number over here, apart from the negative sign, is being increased by 1 and so on and so forth. So that means that if I want to get to the term before this term, I would end up with n minus 6. And if I want to get to the term before this term, I would end up with n minus 5. So I'm going to do this. So meaning that I will write this as n minus 5 factorial. And then this thing over here, I write it as n minus 5 factorial times n minus 4. Or if you want to know why, I write this as basically 1 times 2 times 3 times all the way up to n minus 4, right? And then of course I can write the term that comes before this, which is n minus 5. And of course you can just keep writing all of these terms, but the point is that this part over here is n minus 5 factorial. So then I can write this as n minus 5 factorial over n minus 5 factorial times n minus 4 times n minus 4. So you see, basically there is a whole lot of room for making mistakes here, so you need to be careful. And then you can simplify this and you'll get n minus 4 here in the denominator. So you'll get n times, basically n times 1 divided by n minus 4, which is the same thing as n divided by n minus 4 is equal to 5/3. So that's basically how you simplify that. And then once you've done that, you can probably just simply basically solve this equation, meaning that you can write this as 3n is equal to 5n minus 20. Okay. And what that means is that then -2, -5, and plus 3 is -2 and is equal to -20. So that then these two can cancel out. Divide by 2, 10. Divide by 2, 1. So n is equal to 10. Which is actually the right answer. There's a whole lot of exercises here. Another one which you might actually find a little bit tricky is this one. So you have 5 times 4 permutation r. 4 permutation r is equal to 6 times 5 permutation r minus 1. Okay. Now, if I divide both sides of this equation by for example 5 permutation r minus 1, I would get 5 times 4 permutation r. This is actually 4 permutation. I have to write this up here. 4 permutation r divided by 5 permutation r minus 1, right? And divide this side by the same thing. I'll get a 1 over here, so I'll get a 6. And then that means that then divide basically both sides by a 5. I would get basically 4 permutation r divided by 5 permutation r minus 1 is equal to 6 divided by 5. Now, to rewrite this, I can rewrite this as basically 4 factorial. Of course, a little bit better. I can write this as 4 factorial divided by 4 minus r. 4 minus r factorial divided by 5 factorial divided by basically 5 minus r minus 1, 5 minus r minus 1, 5 minus r minus 1 factorial, which is equal to 5 minus 1 is equal to 4, so 4 minus r factorial. 4 minus r factorial, right? 5 minus r plus 1 actually. So you're supposed to write this as 5 minus r minus 1 factorial, right? This is the denominator, which would be 5 minus r plus 1 factorial, which is the same thing as 6 minus r factorial. 6 minus r factorial. Which is the same thing as 6 minus r factorial. And that is equal to 6/5. Now what I can do here is that I write this up here. I can write this as 4 factorial divided by 4 minus r factorial, and times the reciprocal of this, that would give me 6 minus r factorial divided by 5 factorial. Now 4 factorial and 5 factorial you can simplify, and that is equal to, of course, 6/5. Now 4 factorial and 5 factorial is so basically 4 factorial you can write it as, of course you know that 4 factorial is the same thing as 1 times 2 times 3 times 4. And 5 factorial you can write it as 1 times 2 times 3 times 4 times 5. So that is 4 factorial. So 5 factorial I can write it as 4 factorial times 5. 5 factorial I can write it as 4 factorial times 5. So I write 4 minus r factorial times 4 factorial times 4 factorial times 5, and over here I write 4 factorial 6 minus r factorial is equal to 6/5. And then I can simplify these two, and then of course I can simplify these 5's in the denominator. Now the only thing that needs to be taken care of is these two. Now this is a little bit tricky. Now 6 minus r factorial is the same thing as, of course, 6 minus r factorial is the same thing as 1 times 2 times 3 times all the way up to 6 minus r. And of course the term that comes before this, if you want to get the term that comes before this, you have to subtract 1 from this number, which would be 6 minus r minus 1, which is 6 minus 1 is equal to 5, right? 6 minus 1 is equal to 5 minus r factorial. That's 5 minus r factorial. I'm sorry, 5 minus r and 4 minus r here. And, well, so that is basically about 6 minus r factorial, and you have 4 minus r factorial here. Now this part over here, you can write it as 4 minus r factorial. So this thing I can write it as, so I can write this, the numerator, I don't have to do anything about it, 6 minus r factorial. The denominator, I can write it as no, I'm sorry. No. I made a mistake there, I'm sorry. Okay. So what I meant to say was that 6 minus r factorial, I can write it as 4 minus r factorial, 4 minus r factorial times 5 minus r times 5 minus r times 6 minus r divided by 4 minus r factorial is equal to 6. This 5 we have already simplified, and then you can simplify these two, and so you have 5 minus r times 6 minus r is equal to 6. So that is 5 times 6 is equal to 30 minus 5r minus 6r plus r squared is equal to 6. And so what that means is that r squared minus 11r, and then over here 30 minus 6 is equal to plus 24 is equal to 0. R squared minus 11r plus 24 is equal to 0. And then you have 24 is basically the same thing as 3 times 8. 24 is the same thing as 3 times 8. And negative 8 negative 3 is negative 11. And the product of them would be positive 24. So I write this as r squared minus 3r minus 8r plus 24 is equal to 0. And so taking r out would be r times r minus 3 minus 8 times r minus 3 is equal to 0, which means that r minus 8 times r minus 3 is equal to 0. And so r is equal to 8, or r is equal to 3. And over here we said that basically that is actually the right answer. That is the right answer. Okay, so there is a couple more questions here that I will do in the next video, because I'm running out of time here. I'll see you in the next video.